Hello, I'm Shivan Mishra. So today we are going to discuss the problem 1792 maximum average pass ratio on the LeetCode. Okay, so here there is a school that has classes of students. Each class will be having final exam. You are given a to-do integer array, ठीक pass and total. You know beforehand 5 class. Okay, so we are given for each classes the number of students which are going to be passed and the total number of students which that class currently have. Okay, you are also given an integer extra student. Okay, so these are the extra students which are extremely intelligent. These are brilliant students who are going to pass in any class. If we place them in any class, they are going to be passed. Okay, so we have to maximize the average pass ratio. Okay, so average pass ratio we have to maximize it. Mhm. Okay, so the average pass ratio is the sum of the pass ratios of all classes divided by the number of classes. Okay, return the maximum possible average pass student average answer within 10 to the power minus 5 actual value. Okay, so if we have to calculate for that, what are 3 by 4 plus 3 by 5 and 2 by 2 divided by 3. 3, it is the number of classes and the two brilliant students which we have placed in the first class. So 1 plus 2, 3, and now total students are 4. So 3 by 4 and 3 by 5 and 2 by 2. It is the average and average. We have to maximize the average of pass ratios. So pass ratio average what it is? It is divided by 3 as the number of classes in the same way here. So the point is how are we going to put the student which we want? Sorry, I mean to say how will we know in which class we are going to put the new extra student so that the average is going to get increased. Yes, for that I have derived some formula. So constraint to the power 5, that means we are going to do it in n log max n log n, not more than that. Okay, so the derivation I have done is that. So as you can see here, if the initially our class has x comma y, that is x student pass and y student are the total count of the student. Then after adding one student, how much increase in average we are going to get? So if we increase one student, it is going to get x plus one student who passed and y plus one total number of students in that class. If we increase, if we add one student in that particular class, then that is going to be the average of that class. Means you can say that that is the pass ratio and that is the old pass ratio. So if we solve that particular equation, then we are going, if we simplify it, then we are going to get a generalized formula which is going to give us the increase in pass ratio which we are going to get after adding one student in that particular class. So here we simply try to simplify it and after that we got a result, that is y minus 1 divided by y star y plus 1. It's a basic simple math. I think you are able to understand what I have did here. Just take the LCM of those and then we are going to get like that and x minus y, these both are going to cancel out each other. Then y minus x divided by y plus 1. Yes. So we are going to do what? Whatever's class that value is going to be maximum, we are going to increase one student in that class because that is the average, that is the increase in pass ratio we are going to get from that particular class after adding one student in that class. So if maximized, then our average is going to definitely be maximized. So now let's do it. Okay. So for that, what data structure we can use? We can use the priority queue. Yes, priority queue is best for that purpose. We need a max heap, and just we update the nodes each time. Yes. So let's get started. Okay. Struct node, here node, double val. That value is going to be the value which we have calculated here. Okay. We can simply write it in that way. So the node val actually, and we have write a comparator which we need in to make it our max heap. Because practical is going to be the default min heap, so we have to make it max heap. So that is the comparator function which we have, right? The operator that is node A and node B, it is going to compare that A dot value and with B dot value. If it's smaller than that, then it is going to give us true, which will make it our max heap. If it's true, then it is going to strap it. Yeah. So here we are going to start picking node vector of node and compare that picking here. Hmm, yeah. So now what we need to put all the classes into the priority queue so that we can get the the maximum what we need. Okay. Okay. Now x is c0 and y is c1. We are going to do one minute. Just make sure it's double. Now y is equals to y divided by y star y plus 1. Okay. As per our formula, as y star y plus 1, it can be a long value. So we need to handle it, else it is going to give us runtime error. Now, okay. So 10 10 dot val is val, 10 dot x is x, 10 dot y is equals to y. Now practically push 10. Yes, I think that's it. Okay. So, so now it's okay. Yeah, it's pushed down. Now we need what for each of the extra student we have to do that. Now we are going to push extra student one by one into the classes. Okay. Okay. So mm, so auto top. We are going to get the top of the priority queue. Whatever element, if, whatever the node is at the top, that is whatever the class at the top. That is going to give us the maximum pass ratio if we increase a student in that particular class. Okay. So here y is equals to top y. Okay, double val is equals to what it's going to get. We are going to increase our student in that particular class. It's on y plus plus. Okay, now we are going to again calculate the same thing. So let's take that particular part and just put it here. Yeah, so we have again calculated it and same thing. Okay, everything is same. Now for all the extra students are now placed in whatever classes, they are going to give us our maximum value, maximum pass ratio. Now it is our answer, which is that. Now while the priority queue is not empty, as we have everything in our priority queue, all the classes, whatever we have increased the number of students in whatever classes, these are going to be present in our priority queue. So just we are going to iterate that priority queue and just calculate the pass ratio from there and put it into the answer. And after that, we divide it by the number of classes as we want the average of the pass ratio. Okay, so double average is equals to what? So first of all, what? Okay, so first we have to take the top of that view. Okay, so here we are going to do what? The average. Okay, to make sure it is a double value, we are going to divide it top dot x top dot y. It's going to be answer plus equal to average. Okay, answer equals to divided by n. An answer. I think it's fine now. It's done. I think if we try to run it, it's giving us some error. Why the error? Why it is enter points here? Container node. So the error which we are getting because we haven't removed the old class from here, because we are going to update that particular class, so we have to remove it from our priority queue, and now we are going to add our new class, and in the same way here it is going to give us uh, time limit exceed error, as we are not removing it from here, because we are going to calculate the average for each of the classes, but we are not removing the class, so it is going to always calculate the first, and eventually it's going to give us the time complexity or time complexity exceed the time limit. Now I think it should give us our proper results. Yeah, as you can see, the answer is correct. So let's try to submit it. Let's check that is going to submit or not. Yeah, as you can see here, it's committed. So let's talk about the time complexity and the space complexity of that particular solution. Okay. Here. Um, Okay. Okay. I think it's visible. So mm, as you can see, gratitude here. What we are doing, just we are iterating for the class. So that is going to give us big O of n. Okay. Yeah. Now we are pushing here. So it's going to be the n login. Oh, login. So it is going to be the login. So n time login. Yeah. So n time login. Now here we are going for the each of the extra string. So it's also the end. And for the push login, so the max time complexity is going to be n login. So okay. So for the space, as we are going to push all the classes and we are going to only update them. So the space complexity is going to be go often. So you can say that the time complexity is big O n login, and the space complexity is big O of n. You can say that. So understood? You can say that the time complexity is n login and space complexity is login. I hope you understood why I'm saying that, because n and the priority queue stuff, these are the login. The, these are the login and similar, and it is big O of n. So you can say that. So I think that's all from our side. If you like it. If you have any suggestions, please comment it. As if my second video, so please tell me if I need to make any improvement. I will try to make some improvement if I can. Please suggest some changes if you